Okay, so welcome back to another video. So here we have a functional equation that we'd like to solve, and that is to find all functions f mapped from the reals to the reals, such that for x and y that are real numbers, we have that it must satisfy the following conditions. We have that f of x is greater than or equal to e to the 2011 times x, and then f of x plus y is greater than or equal to f of x times f of y. So when we solve for functional equations, of course, the objective is to find all functions satisfying, your conditions. Typically, when you're solving these kinds of problems, the more of the easier approach, or rather, it's the most common approach, is the more of the guess and check. Mainly when you deal with stuff that you want to deal with some value of 0 and seeing what kind of result that you can get out of it to understand what relationship or patterns can occur from it. Here in this case, we don't need to use the 0 value power to show, because that's not what we're trying to approach with. Instead, we're going to actually take things a little bit of different of a guess and check. Since we have two different inequalities, I'll call one statement, we'll call that p of x for this statement since it only supports one input. And then a second, we'll call that statement q, but two values x and y, since there's an x and a y value that we need to figure out like what behavior is going on from here. So this is actually more of an easier functional equation to solve here. It's nothing too convoluted, and unlike the other ones that I did in the past. Well, meanwhile, it's one expression and it's not dealing with inequalities, at least I can remember that from the top of my head. But this is actually more of the, tamer ones and a little bit easier to that approach. So anyway, just with that, let's actually just get started. As mentioned, I'll let p of x represent our first inequality. So p of x, I'll just denote this arrow, so that's f of x greater than or equal to e to the 2011 times x, and then we'll let the second statement supporting two inputs, q of x, y, let that be f of x plus y greater than or equal to f of x times f of y. So what do we do something from here? Let's actually take a look at our p of x statement. So f of x is greater than or equal to e to the 2011 times x. One thing to note and I'm sure you can probably guess this as well, is that we can say that f of x is greater than 0 strictly, well, not strictly, but it's also mainly because the exponential function is always going to be positive. So with this in hand, we'll come back to more details with that, but now let's go back to the q to the x, y statement. So what I'm gonna do is I'll let y equals 0. So from p of x, and let me just put that statement here. So if I plug q and then x, then 0, so what that implies is what we'll have is over here is f of x plus 0, then greater than f of x, then times f of 0. Of course, this is the same thing as f of x greater than f of x times f of 0. And then what I can do is just divide the f of x to both sides. And of course, this will yield us f of 0 is less than or equal to 1. Okay, so with this coming in handy, so what else can we say from here? So if I go back to our p of x statement, so now let's plug in x for 0 for the p statement. So p0 then implies f of 0 is greater than e to the 2011 times 0. That has to further imply that f of 0 is 2011 times 0 is 0, then e to the 1 is just 1. So that means it's greater than 1. So take a look at this. I have a f of 0 less than or equal to 1, and I have a f of 0 greater than or equal to 1. So what conclusion can we draw from this? We can actually give the implication and say that indeed that f of 0 is indeed equal to 1. So that's going to be very important for the process up ahead. So let's actually just denote this important observation that we made. Now to continue forward, going back to our q statement, qxy statement. So now let's actually suppose that we let y equals negative x. So q, x, and then negative x. So if I plug this back in, so that means f of x then minus x is greater than or equal to f of x then times f of negative x. And so in other words, that's the same thing as f of 0, which we just said that this was equal to 1, is less than or equal to f of x times f of negative x. What I'll do here is I'll divide a f of negative x to both sides. So that gives us that 1 divided by f of negative x is less than or equal to f of x, right? Just like that. So far, Doesn't seem like anything important yet, but we're going to get to that eventually. So going back to our P statement, let's now plug in negative x for this input over here for this inequality. So P of negative x, so in other words, that's the same thing. We'll write that as f of negative x is greater than or equal to 2011, e to the power negative 2011 x. And so let's just rewrite this again to say that so far that, again, recall that we said that our given is f of x is greater than e to the 2011 x. So why is this important? So what we can do here is everything that we just done so far. We have our f of 0 is equal to 1. We have this inequality that we showed that 1 over f of negative x and then greater than or equal to f of x. And then we have these two results, one that we just found and another one that's our given. Combining all this together, we can yield this little nice result to say that e to the 2011 x, which is indeed the same thing as 1 divided by e to the negative 2011 x, which going back to over here, that if we flip the reciprocal, then that means that gives us the same thing as the condition over here, but that's just also switching to signs as well. So indeed, that's the same thing as writing as greater than or equal to 1 divided by f of negative x, which is going back to this inequality to say that this is greater than f of x, which of course that says that with our given condition that f of x is greater than e to the 2011 x. And so with this, now if we take a look at the extreme left-hand side and the extreme right-hand side and take a look at our inequalities and the equality signs, we've seen that these two actually matches with everything put together. And so therefore to the conclusion and say that combining all this together in one, that our only function that satisfies the given, our two givens inequality, is that f of x is indeed just equal to e to the power 2011 x. And for, of course, x being in the reals. So just like that, we found our only function that satisfies the following, and actually that completes our functional equation evaluation just like that. So yeah, that's pretty cool if you ask me.